Hi Facebook, we're live at NASA's Goddard Space Flight Center. I'm Erin Kislick and you are live in 360 at the Hubble Space Telescope Operations Control Center. Take a look around. This place is the heart, the soul, and the brains of the Hubble Space Telescope, who launched 28 years ago today. Speaking of brains, we've got a couple pretty smart folks here to answer your questions, so send them all in to the comment section below and we'll try to get to as many as we can during the show and even a few after it's ended. So without further ado, we've got Deputy Project Manager Jim Jeletic.
Hi, Erin.
Hey, Jim. Thanks so much for being here.
Thanks for having me.
So Hubble, it's an iconic mission, but it's not so young anymore. How's Hubble doing?
Well, science-wise, it's at the peak of its scientific capability, so it's been doing great. In fact, this year we had more papers published on its discoveries than ever in its 28-year history. And as far as the spacecraft is concerned, you know, even with all those parts that are on it that have been flying in the harsh environment of space for 28 years, we still have redundancy in all of its critical systems. So we're hopeful that we can continue to make these groundbreaking observations well into the next decade.
Into the next decade. So when Hubble was launched, it had a life expectancy of about 15 years. How have we managed to double that?
Well, you know, we had 5 servicing missions that we went up on the space shuttle with astronauts, and they repaired and replaced and upgraded its hardware over time. And it's kind of like your cell phone. You know, when you get a new cell phone, you get a better camera on it, high resolution, and you can take even better pictures. Well, we did that with the instruments on Hubble. So because of that, it's at this peak of its capability. And we're hopeful that we can continually change our fundamental understanding of the universe for years to come with it.
That sounds great. I just want to remind anyone just tuning in that we're at NASA's Goddard Space Flight Center in Hubble Space Telescope Operations Control Center. We're in 360, so take a look around while I introduce our next guest. We have Senior Project Scientist Jennifer Wiseman joining us today. Hi.
Hi, Erin.
Thank you so much for being here.
My pleasure.
So you've been on this mission for about 11 years. Does Hubble still do anything or show you anything that surprises you?
Oh my goodness, every year Hubble is surprising us. We're looking at things with Hubble now that we didn't even imagine we would be observing when it was launched back in 1990. For example, we're studying the atmospheres of planets outside our solar system. And we've recently observed light coming from a merger of neutron stars. This event also created gravitational waves. So these are kinds of phenomena we didn't even imagine decades ago.
That's amazing, and I hear that Hubble sent us something amazing for its own anniversary. Can we talk about this image here?
We have this great image of the Lagoon Nebula. So this is a region of gas and dust that's being churned up by star formation. You can see a lot of features like pillars and clumps of gas. It's lit up because one of the stars that have recently formed is a monster star. It's about 200,000 times brighter than our sun. And it's ionizing the gas, it's creating these structures, its winds and radiation are carving out these various pillars and globules. And so we like to think of this as kind of a stellar nursery.
That's amazing. So are these two different parts of the nebula? Why do they look so different?
So you see 2 images here, but they're actually the same place. They're both the same region of the Lagoon Nebula, but they're looking at it with different kinds of light. So Hubble can see both visible light, like our eyes can see, and that's what we see here on the left, and also infrared light, which is what you see here on the right. And so in infrared light, we can actually see through a lot of the dusty veil in front of and within the nebula. You can see a lot of stars behind it. You can see some stars within the nebula, and you can see these very dark globules where new, smaller stars are still incubating. So it's wonderful to have Hubble's panchromatic view of all these different colors. It gives us different information.
That's amazing. And so how far away about is this?
So the nebula is about 4,000 light years away. That's a unit of distance that we use. It basically means that the light started its journey to us about 4,000 years ago. Think about what was happening on Earth at that time, and that's when the light started traveling to us.
That is extremely impressive. Yeah. So for our viewers at home, we're at NASA's Goddard Space Flight Center inside Hubble Space Telescope Operations Control Center. And now I'm going to jump over and ask someone really cool to speak with me if he has a second. We've got systems engineer Mike Wentz. Hi, thank you so much for being here.
Hi, Aaron. You're perfectly welcome.
So can you tell us a little bit about what goes on in this room?
Yeah, this is actually the building where we control the Hubble Space Telescope. We'll send commands up to it, and we'll also receive telemetry down from it, so we can actually see how the instruments are doing and how the telescope are doing. In this room right here, this is where the systems engineers will work for various circumstances. This is actually where we did support the servicing missions that Jim talked about when we were replacing the instruments on Hubble. That was a lot of fun working with the astronauts. But we use this room now for mainly two reasons. One of them is if we happen to have some sort of anomaly on the spacecraft, which is where the spacecraft does something we weren't quite expecting. And so the systems engineers will come in here and we'll try to figure out what's going on and why it happened and what can we do to make it not happen again. And we'll also use this room for testing. If we're going to be sending up new software to the instruments or new software to the telescope, we got to make sure we test it out on the ground beforehand, because you don't want to be testing it out on the spacecraft itself.
Okay, so trick question. What is something that Hubble would do that would fall under that unexpected category?
Well, one of the small anomalies that we have fairly recently, probably about once or maybe even twice a week, is there are instruments on the Hubble that allow us to point the telescope very accurately. To be able to take the images that Jennifer was talking about, you have to be able to point and hold the telescope extremely accurately. In fact, we have to be able to focus essentially on the width of a human hair held at 1 mile distance. To be able to do that, we have these instruments known as defined guidance sensors. They lock up on stars. They actually find a star and they lock and they hold it. But every once in a while, they'll try to lock up on the star and they can't do it. And they sort of send information down saying, we can't do it, we can't do it. So we actually have to come in here, and what actually we find is that they actually are made to lock up on single stars. A lot of stars out there aren't single stars, but we don't know about it on the ground yet, because no one on the ground can tell that these stars are double stars or binary stars. And so Hubble makes these discoveries when it actually has these anomalies.
It's quite the silver lining. So how about you? What is your role? How long have you been working with Hubble?
I'm a systems engineer here. I've been actually on Hubble for 26 years, and so I'm one of the older guys around who've been here for a lot of it. I'm actually in charge of those fine guidance sensors. Those are the instruments I actually have to take care of, and so I actually get to be able to come in here and find all the new double stars and variable stars that Hubble has found just because it's had trouble.
That's an amazing job. I'll let you get back to work, but thank you so much for your time.
Thank you.
All right, so we're going to start taking some of your questions. Continue to send them in. We're going to be taking them here, and then also after the show's over, we'll be answering them in the comments section below. So let's see what we've got here. So Tia from Twitter asks, how do you deal with damages made by impacts from space objects on Hubble? That's an interesting one. You want to take that, Jim?
Sure. So it's a great question. We actually look for major impacts so that we can actually turn the telescope to be as small a surface area as possible, so they'll avoid us if we know one's coming, it's big enough. But for the most part, it gets hit. And so far, I think we've been really lucky in that nothing's hit us that has caused anything really to break. So we're going to keep our fingers crossed here for the next however many years.
Long live Hubble. All right. So Dan asks, what's the furthest point in light years that Hubble has seen? I'll leave that to you, Jennifer.
That's a very good question. So we're trying to see objects in space farther and farther out. As the cameras on Hubble have improved over the years because of these astronaut servicing missions, we've had more sensitivity. So right now we're seeing emission from galaxies in the very distant universe that are in the process of forming more than 13 billion light years away. So we know the universe seems to be about 13.8 billion years old, and we're seeing these baby galaxies form from within the first 0.8 of that 13.8 billion years. In fact, within the first few 100 million years, we're seeing these infant galaxies start to form. And the upcoming James Webb Space Telescope will be able to see even farther because it has infrared capabilities that'll help us to see even farther back in time as light travels through this expanding universe and gets stretched to redder and redder wavelengths of light.
Thanks. All right, let's see what we've got next. Well, I guess on that same note, what has Hubble found out about the beginning of the universe?
Well, Hubble cannot see all the way back to the very beginning. There's a time before radiation could even escape for us to see. But we're able to see pretty close to within, like I said, the first 0.8 of the 13.8 billion year history of the universe. And what we've learned is that galaxies formed early on. Galaxies are collections of stars and gas and dark matter. Stars formed early on. These gravitational collections of material grew over time. We can now see with Hubble, by looking far out in space, which means looking back in time, that galaxies were once quite small and irregular looking, and then they merged together many times to grow into the bigger type galaxies like our Milky Way. So we've been able to see with Hubble that galaxies began small, they grew over time, and now we have galaxies that have had the privilege of having several generations of stars, massive stars, come and go, and that's given us heavier elements like carbon and oxygen, things we need for planets and life.
Thank you so much. Unfortunately, I think we're going to have to get out of here and let these folks get back to work. But I want to thank you all for joining us. And please continue to send in your questions. We'll get to some of them in the comment section below. Take one last look around the room before we leave. And if you want to know anything more about Hubble, you can always find us on nasa.gov/Hubble or on social media at NASA Hubble. Thank you both so much for being here today.
Thank you.
Let's get on out of here. Thanks, Mike.